All right, we're about to take a journey back to the very beginning. And I don't mean the beginning of a country or even our planet, but the beginning of time itself. We're going to dive into what is arguably the single most important second in the entire 13.8 billion year history of our universe.
You know, it's pretty much the biggest question we can possibly ask, right? It's where physics and philosophy kind of blur together. How did, well, everything come from nothing? Now, the absolute very first instant is still a total mystery. But the story of what happened right after, well, that is one of the most incredible tales science has ever pieced together.
So where do we even begin this story? Well, it starts in a place our science can barely even describe. A moment so extreme, so ancient, that the very laws of physics that we rely on, they just completely break down.
Just look at that number, 10 to the minus 43 seconds. That is a decimal point, followed by 42 zeros and then a 1. It's an impossibly small slice of time. And in that moment, our entire observable universe was crammed into a space trillions of times smaller than a single proton and heated to a temperature that's just, it's a number with so many zeros I can't even say it. Welcome to the Planck Era.
And this is where we hit a massive wall. Our two greatest theories of physics. You've got Einstein's general relativity, which is all about gravity and huge things like stars and galaxies. And then you have quantum mechanics, which handles all the weirdness of the tiny subatomic world. At this scale, they are completely incompatible. They just don't play nice together. It's like having two different instruction manuals for reality that totally contradict each other.
So what was it actually like in there? Well, the physicist John Wheeler called it quantum foam. Try to picture this. A chaotic, bubbling soup where space and time are just flickering in and out of existence. Tiny little wormholes could pop up out of nowhere and then vanish in an instant. For this tiniest fraction of a moment, the basic rules we live by, cause and effect, they just didn't exist.
Okay, so out of that chaos, the universe started to expand. But the simple idea of a nice, smooth expansion, it didn't really add up. When scientists did the math, they found these huge cosmic puzzles, plot holes really, that for decades nobody had a good answer for.
There were three really big ones. First, the horizon problem. How can opposite sides of the universe, which are billions of light years apart, be the exact same temperature? There's no way they could have ever been in contact to even things out. Second, the flatness problem. It turns out the geometry of our universe is perfectly flat, which is about as likely as flipping a coin a billion times and having it land on its edge every single time. And finally, the monopole problem. Our theory said we should have created tons of magnets with only a north or a south pole, but we have never, ever found one.
And then, in 1979, a physicist named Alan Guth had this absolutely brilliant idea, cosmic inflation. He suggested that in the first tiny, tiny fraction of a second, the universe went through a period of insane, hyper-accelerated, exponential expansion. And this one idea, it just elegantly solved all three problems at once.
And when I say fast, that is a massive understatement. In way less than a trillionth of a second, the universe blew up by a factor of an octillion. That's a 1 with 27 zeros. This wasn't a gentle expansion. This was a truly violent, explosive event. This really put the bang in the Big Bang.
To really get a handle on how powerful this exponential growth is, just think about folding a piece of paper. If you could fold it 42 times, it would reach the moon. But if you could fold it 90 times, which is about how many times the universe doubled in size, that single sheet of paper would be wider than our entire supercluster of galaxies. That is the insane power of cosmic inflation.
So, after that incredible expansion, the universe was suddenly huge, cold, and pretty much empty. But all the energy from that inflation event reheated the cosmos, basically setting the stage for the creation of, well, everything we know.
In the extreme heat right after the Big Bang, the four fundamental forces of nature, gravity, electromagnetism, and the strong and weak nuclear forces, they weren't separate things. They were all merged together into a single super force.
Think of it like a spinning coin. While it's spinning super fast, that's our hot early universe, you can't tell if it's heads or tails. It's just a blur. But as the coin slows down and settles, just like the universe cooled down, the distinct faces of heads and tails finally appear. The forces froze out and became separate, one after the other.
And this all happened at a speed that is just unbelievable. By a mere trillionth of a second, the Higgs field switched on, giving particles their mass. Just a moment later, at 1/1,000,000th of a second, quarks started sticking together, forming the very first protons and neutrons. And by the time the universe was only 1 second old, all the basic ingredients were already in place.
But there was a cosmic war brewing. See, for every single particle of matter that was created, a particle of antimatter was also born. Now, physics says they should have found each other and completely annihilated, leaving behind a universe with nothing in it but light. But, for some reason we still don't totally get, there was a tiny, tiny flaw in this symmetry. For every billion annihilations, just one single particle of matter was left over.
And that tiny 1 in a billion leftover, that's everything. Every star, every planet, you, me, all of it. And another crucial imbalance was set right then. The universe ended up with roughly 7 protons for every 1 neutron. Without that very specific ratio, the chemistry you need to build stars and heavier elements just wouldn't be possible. So in a very real sense, our existence was baked into the recipe from the very first second.
So, we've got matter, we've got forces, but the story is not over, not by a long shot. For hundreds of thousands of years, the universe was a place where light itself was basically trapped. I want you to imagine a thick, glowing, super hot fog. That's what the early universe was like. It was this dense plasma of charged protons and electrons, and particles of light, photons, couldn't go more than a few steps without bumping into something and getting scattered. The entire universe was completely opaque.
But the universe kept expanding, and as it expanded, it cooled. And for 380,000 years, this went on, until it finally reached a critical turning point. The temperature dropped all the way down to about 3,000 Kelvin.
And at that temperature, everything changed. It was finally cool enough for electrons to be captured by protons, forming the first stable neutral atoms. And with all those charged particles now locked away, there was nothing left to scatter the light. In an instant, the cosmic fog cleared, and the entire universe became transparent for the very first time.
So what happened to all those photons that had been trapped for so long? They were finally set free, and they started streaming across the cosmos totally unimpeded. And that incredible burst of ancient light, now stretched out by the expansion of space into microwave wavelengths, is what we can still detect today as the cosmic microwave background, or the CMB.
When we look at a map of the CMB, what we are seeing is the oldest light in the universe. It is, quite literally, a baby picture of the cosmos, snapped when it was just a toddler at 380,000 years old. And this picture, it isn't just a uniform glow. It's filled with these tiny little temperature fluctuations. Those are the imprints of quantum jitters from the first moments of time, magnified to cosmic scales by inflation. These tiny ripples are the seeds that gravity would later grow into every single galaxy, star, and planet we see today. It's the starting point for everything that came after, and believe me, it still holds secrets we are just beginning to figure out.